Hey guys, today we are going to be doing this chemistry problem, and I'm just going to get straight into it. So there's more parts to it, but I'm only going to do part A because part B, C, and D are basically like part A with different reactions. I've just opened my calculator out by me. So we are going to calculate the delta H, delta S, and delta G of this reaction right here. Delta H is in the enthalpy, delta S is in the entropy, delta G is in the free energy. Now, we know that, given here, we know that delta G is equal to delta H minus temperature times the entropy, and these are all formation, right? So this means that clearly, in order to get delta G, we're going to have to solve for enthalpy and entropy first. So let's start off with enthalpy, and you're going to get some guidance on a multiple choice because you're kind of given the idea of how you need to go about it. But we're going to use the summation idea. So for delta H, we're going to use the summation idea, which states that the sum of the number of products times the enthalpy of the formation of those products minus the same thing, the sum of the number of reagents times the enthalpy of formation for these reagents is equal to delta H. So let's just go ahead and get straight into it. So products become before reagents. So that means CO2 and 2H2O are going to come before CH4 and 2O2. Now, so that means that delta H of standard is going to equal CO2 is 1. That's only one molecule. So I'm only going to put the value of CO2 right here once. So I'm going to put negative 393.5 plus, and then I have 2 waters. So 2 times the value for water, negative 242. Close parentheses, these will be added together because this is the whole product section. Sum means when you add them all together, right? So the sum of the products added subtracted by the reagents. But you're multiplying inside each molecule, but you're adding between 2 on the same side. Then subtract that by the sum of the reactants. So now we have 2O2 and CH4. I'm going to start with CH4. And if you go over here and you look at 2O2, it's 0 because it's in its standard state as a gas. Its enthalpy is 0. So it's only going to be minus 1 enthalpy of formation for CH4 or methane because there's only 1 there. And we see that that's negative 75 kilojoules. And note that this whole thing is going to be in kilojoules. This is important at the end. So basically, I'm adding 75. And once you do all the calculations for this, you should get about 802 point something. I'm going to round it to 803 kilojoules. Now, I have my delta H, which is this. So I have this part, right? So now we're going to solve for delta S, which is entropy. Our temperature is actually given to us. Sorry, I didn't write that here, but it is 298 Kelvin, which is also at standard form. If we don't know that, I'm gonna put 10, which is also 25 degrees Celsius. So it is in standard state. So that's why you have that basically. Okay. So now we have our entropy, delta S equals. So you basically the same idea. For entropy, you're going to do a summation idea. I'm not really going to rewrite this whole idea here, but you get the point. So now, instead of using delta H of formation, I'm literally going to cross that out. We're going to use delta S. So we're going to start again with the products. We have CO2, which is 214, and there's only 1 CO2. So basically 214 times 1, or just 214, plus 2 times how much water is, which is 189, and then that minus 1 CH4, which is 186. Oh, this is in joules per Kelvin, so you're gonna have to convert Kelvin times mole. Okay, 186 plus 2. I have 2O2, so 2 times 205, and that will. Oh, I'm missing a parentheses. And that will give you negative 4 joules per Kelvin. I'm going to highlight that, and that's for here. So now I have my temperature, right? It's in standard. It's going to be in Kelvin, by the way. But I have an issue here. There are different units, which you know that you cannot work with that. So in order to fix this, I'm going to convert my kilojoules to joules. So I'm going to take, basically, what I'm doing here is negative 803 kilojoules, and I'm going to multiply it by 1,000. I'm going to multiply it by 1,000 to give me negative 803 E3 joules. Now I'm going to plug that all into this equation right here. So delta G formation equals the negative 803 E3 joules minus T times delta S, which is negative 4. Oh, sorry, T is negative 298, by the way. T is always in Kelvin, times negative 4. Okay, now, you can also do summation here because they're giving you this, which would be easier, right? But typically, let's say they're only asking you for the free energy and they're giving you all this, then you would obviously probably do a summation. But the thing is, they're asking you for each step, so you might as well just calculate it, and then instead of having to do this, you just add them, which is easier, right? Okay, sorry, you plug them in. But, okay, so now we have delta G, and when you plug all these values into a calculator, you're going to get that delta G equals negative 801 kilojoule, 802, but I guess it's something, 801 kilojoules. I got it in joules, I converted it. I'm just letting you guys know it was 8.018 E5 joules. And that is your answer, and that's how you would do a summation problem. It can look intimidating, but it's honestly one of the easier problems. So yeah.